Hi, we are going to discuss on examples from notes chapter 7. So we are going to look at example 11. In example 11, an object is placed a 90 centimeter from a glass lens with one concave surface of a radius 22 centimeter and one convex surface of a radius of 18.5 centimeter. Determine the image position and linear magnification. So in the question, you have object is placed 90 centimeter from the glass lens, which means that your object distance is given as 90 centimeter. And in our syllabus, we only look at the real object. So our U here is a positive one. So we have a real object here of 90 centimeter from glass lens. And that glass lens has a refractive index of 1.56. Refractive index sebanyak 1.56 here. And then our lens here has been made up of one concave surface and one convex surface. So when we have two different surfaces here, concave and convex, we call this as a meniscus type. So our lens here is a meniscus type lens, where in meniscus, you have two types. One is convex meniscus, and another one is a concave meniscus. So bentuk convex meniscus here is like this. Ini bentuk convex meniscus. Dia macam sabit sikit. And bentuk concave meniscus is something similar to that. Okay, this is your concave meniscus. Alright, what happened here is both these meniscus has two different surfaces. If you look at the convex meniscus, when you look from this side, it forms a concave. So it has a concave surface, concave. And when you look from this side, you have a convex surface. So it has a convex surface. Begitu juga for concave meniscus, when you look from this side, it forms a concave surface, concave. And when you look from this side pula, you get a convex surface. So, bila kita ada dua jenis permukaan, convex dan concave, kita panggil dia meniscus. Jenis lens dia adalah meniscus. However, now you should be able to deduce meniscus in the question here is either convex ataupun concave. Dia ada syarat dia. Okay, for convex meniscus, the radius of convex surface must be smaller than the radius of a concave surface. Whereas for concave meniscus pula, radius of the concave meniscus yang akan kecil daripada radius of the convex meniscus. So now you look back at the question here. In the question mentioned that one concave surface of radius 22 centimeter. So your concave here, R concave is 22 centimeter. And your R convex here is 18.5 centimeter. So your convex is 18.5 centimeter. So this indicates that your convex is smaller, which means dia adalah convex meniscus because the convex radius is smaller. This one is much smaller than this one. So now we have managed to deduce the shape of the meniscus here. We know the lens here, we have a convex meniscus. So next we are going to find what the question asks us to find, which is the image position V and the linear magnification M here. Okay, so now to answer the question asks image position. So to find image position, we're going to use the lens equation. 1 over F is equal to 1 over V plus 1 over U plus 1 over V. We have information on U. We are looking for V and we do not have any information on F. However, we can find the focal length here. By using the lens maker equation, which is 1 over F is equals to N material over N medium minus 1 multiplied with 1 over R1 minus 1 over R2. So what we have here, the material is the material your lens has been made of, which is 1.56, and the medium here is your lens has been placed in the air, as it is not mentioned, so it is air. So it has a medium of 1, and then minus 1, and then 1 over R1. Okay, so since it is a convex meniscus, you have to make sure your light ray comes from the same side and hit the surfaces. So let's say we have our light ray coming from the left. It hits the first surface, and then it comes and it hits the second surface. So the first surface that the light ray encounter is a concave. Okay, concave. So your R here becomes negative R. So R here is a negative R. Negative. Concave was 22 centimeter. And then the next surface that your light hit is also a concave surface. R is equals to negative 18.5 centimeter. Do not get confused with the surface that we have mentioned earlier to deduce the shape of the lens. Tadi tu adalah to identify the type of the lens. So you have to view from both the side. Kena pandang dari kiri dan kanan untuk tengok permukaan yang kita ada on both side. Okay, however, when you want to substitute in the equation, lens maker equation for your R here, you have to make sure the light ray is going to come from the same side. Kalau kiri-kiri, kalau kanan, kanan. And then you deduce the shape of, and then you deduce the surface and you substitute your sign convention here. Since we have both is negative, negative 22 minus 1 over negative 18.5, and then you're going to press your calculator and you will end up with your F is equals to 207.65 centimeter. So once you have got your F here, you're going to substitute the F into the equation here. 1 over F is equals to 1 over V plus 1 over U. Alright, another thing here to double confirm that the shape of the lens that you have got here is the right one, you can look at the answer that you have got for your F. The F that you have got here is a positive F. Positive F indicates that it is a convex lens. Focal length becomes positive if it's a convex lens. Convex meniscus is a convex lens which is converging, maka the F here is positive. So ngam lah tu. And then we're going to substitute in 1 over 207.65. 1 over U is 90 centimeter plus with 1 over V. You do your max and you will end up with negative 158.85 centimeter. The negative here indicates that your image is virtual image. Okay, next we're going to find the magnification, linear magnification. So the linear magnification here, M is equals to negative V over U. Since I have the information on my V and U, I'm going to use this one. So negative. When you want to substitute your V, substitute the whole V with the negative semua. This is all the characteristic of the V that you have obtained. So do not neglect the V here. Must consider the V, divide by 90 and you will end up with 1.76. Okay, so your magnification is 1.76.